implies like C or D. What this means, right, is that if A and B is true, then this stuff on the right is true. Right? That's what this statement means. So if both these things on the left are true, then we can conclude this or statement on the right. That's going to be important because parentheses are going to matter once we start getting into rules. So if we take an even more complex statement like this, right, we still recognize that this is the left side of an or statement, right? These are the two sides of the if then statement, rather, right? You need all of the, it's an if then statement. This is the major operator. It's the thing most outside of parentheses. And that's going to be important for our rules. And the meat of the session is, and I'll post in event chat. Let me go ahead and post a screen grab of the image that I had. And this is like, again, this is the Bible for the course. It's called logicrules.png. And you should consider having it up. We're going to be discussing the 8 implication rules today and how they work. So unlike a truth table, where it's kind of brute forcing things together, natural deduction works this way. So we'll have premise 1, which will be some junk, right? We'll have P2, which will be some junk, right? Maybe we'll have a P3, some more junk. And then we will separate the conclusion out here, and then that will be the conclusion. Now, the way that natural deduction is going to work is after this, we're going to write justification lines. And what those will be is an output. Then you'll write a rule. And then you'll write line numbers like this. This is going to be the general format. And we keep going with this. We write an output with a rule. Like this might be 4 and 3. And then till at the last line, we will write eventually the conclusion, which will also be justified by a rule and some lines, maybe like 2 and 5, for example. And then at this point, once we have written the conclusion justified by our rules, which I misspelled because spelling is not my strong suit, we can put a star or a happy face by it because we just won the game. So again, the setup is you put your premises here, you put your conclusion here, and then you are using the rules on the sheet to justify a certain output. And you keep doing that until you get to a conclusion. So if we can take a look at our rules and how to read them. So Modus Tollens is the simplest rule. I'm looking right here at Modus Tollens. So the way that the rules are written is the top 2 things above the line is what you need, and the bottom line is the output. Okay, so here if I have if P then Q, whatever P and Q may happen to be, and I have the left side, this P, right? If I have the left side, then I'm justified in writing Q by Modus Tollens. So let's take a simple example. Maybe even something similar to our previous example. So if I had something like this, if P and Q, then D, and then I'm going to say if D is true, then G is true. I don't need this third premise. I'm not going to use the third premise. Oh, I do need a third premise, actually. P3, I'm going to say P and Q is true. And I want my conclusion to be G. So I'm just going to go ahead and do this one to show you how it works. So remembering our Modus Tollens rule, right? Modus Tollens says that if I have if P then Q, and I have the left side, then I can write the right side. So I notice that this P and Q here is the left side of this if-then statement, right? So then I can, oh no, bad move. So then I can write D, and I will write the shortcut MP, and I am using lines 3 and lines 1. Because lines 3 and lines 1 match up with the form of modus ponens. So I can write 1, 3. Then in 5, I can do the same thing. Now that I have this D, I see that it's the left side of P2 and it's an if-then statement. So again, making the same mistake, I can write G by modus ponens of lines 4 and lines 2. Here, the conclusion matches, right? And I win the game. And that's how proofs work, basically. Any questions with this so far?
I'm a little confused about the numbers.
Okay.
Like modus ponens 1 and 3, is that just saying premise 1 and premise 3?
Yeah, we don't really need P1 and P2.
Yeah, is there an order?
The order doesn't matter here. This order
Okay,
doesn't
because
matter.
4-2, yeah.
This order doesn't matter.
Okay, so then in 4 and 5, you're just saying because of 1 and 3, and then in number 5, you're saying because of 4 and 2.
Yeah, right, because line 4 here and line 2 here match with my modus ponens rule.
Yeah.
Right? It matches with my modus ponens rule.
Yeah.
That's all I'm trying to say.
It's gonna be a stupid question.
Go for it.
What is modus?
Oh,
ponens?
and 5 is also a modus ponens. So you basically just pointed out there's 2 modus ponens in there?
Yeah, correct, right? Because like in line 5, right, I'm using this line 4 that I derived, and then I'm using premise 2. To answer Pancake's question, I do not know the Latin meaning of the term, but modus
You don't
ponens is just the rule. That's just the
So
name of the
it's
rule.
just oh, okay. So just the name of the rule. Okay.
Yeah, I'm just telling you what form I get. Why
I
I'm
think it
getting
means easy mode.
I'll be right
Right.
back. My parents just dropped me off some chicken nuggets.
okay.
What
That's
is the
cool.
purpose or point? Shh, children, please. What is the point of modus ponens?
The point of modus ponens is saying that if I tell you, hey, let's take a simple so if I have apples, then I have a basket. This is my favorite rule. Right? We translate this as if A, then
B.
B, right? I then
Wait.
tell you I have apples, right? Which
What
is
do you
A.
do?
And so then therefore we can conclude through modus ponens that I have a basket. And this would be
So
modus ponens.
can this work if we be like I have chicken? Do I have nuggets?
I
I
mean
think Gracie and Javon are here to joke around.
I
No,
mean,
like
yes.
or
you
like like if I have a phone, would it be like a brand or something like
What's
that?
A? What's A with B, dude?
Oh, okay.
Yeah, so like you could say if I have a phone, then it is a Samsung. Right? I have a phone. Therefore, it is a Samsung.
So it's kind of like a math equation, but with like English. Okay, this makes sense.
Yeah, correct. Exactly. That's how modus ponens works. So
I learned more in this one like sentence than I did in all of my online school.
well, thank you, I guess.
Yeah, I'm definitely. I feel like I'm learning more, for sure.
So then we have this is modus ponens, and she works like that, and then her cousin is modus tollens. So modus tollens is interesting because it says that if I have the negation, the negative of the right side, then I get the negative of the left side. Again, looking at this, if P then Q, then not Q, therefore not P. So sticking with the phone example, if I have a phone, then it is a Samsung, right? I would say, right? I do not have a Samsung, ergo or thus, right? I do not have a phone. Right.
That make yeah.
Right. Now you can do for people who were here last time, you can do a truth table for all of these rules and they will be valid arguments. You could do that. or you could just trust me. I would prefer you just trust me because truth tables are tedious. So,
What
yeah.
if you had a phone, but it was iPhone?
Well, then that would mean that this statement is false, right?
Yeah.
Then that statement is just false and the argument is unsound, but it would be a valid argument, but it's just not true in reality. We're
Okay.
looking at the form of argument, not if it actually pertains to reality or not. We're just testing to
Okay.
see if the premises were to be true. If they were true in reality, does that mean we are justified in our conclusion? If they were true,
Okay.
you would need a separate argument to justify each of these premises, though. Like, this is obviously
Yeah.
false. That's obviously false. Like, that's just not true. But we're just rolling with it. So let's take an example of how Modus Tollens can be useful and how you can do combos. So let's take this argument. It should look familiar, pretty familiar. A or B is true. If A or B is true, then C is true. I'm going to tell you that C is not true, so not C. 3. Yeah, no Nazi jokes. I just mean not C, not Nazi, but whatever. Then I'm going to say that if it is false that A or B is true, then I am going to tell you that D is true. And I want you to tell me how D is true. Okay. Again, reading it again. If A or B is true, then C is true. That's P1. Premise 2 is C is false. And then premise 3 is if A or B isn't true, then D would be true. So the way that we would work this out is we see that lines 2 and 1 give us a modus tollens because it fits the form that we see over here. Right? It fits this form. So we write the, pardon? We write the negative of the left side, which here would be not A or B. This is justified through modus tollens of 1, 2. And then in 5, does anybody see how I can get the conclusion here?
D is justified by 2.
Okay, so how am I? So I have this line 4, right? I'm trying to get D, right? That's what this is telling me. It says try to get D. So I'm looking around and I see that D is in line 3. So what rule can I apply using line 3 and any of the other lines to write D?
MT, 3, 2.
So MT, right? Your idea is 3, 2.
I'm guessing.
Okay,
I'm still
yeah.
trying to
See,
understand.
the problem is not C is not the right side of the if-then statement. So we can't apply MT because MT says we need the negation of the right side.
I think we could do a modus ponens with 3 and 4.
That is correct. We can do a modus ponens with 3 and 4.
That's what you meant by combination. Oh.
Yes. Correct, Arco. Good job.
Thank you.
Good job. So you see that this right here is the left side of 3. So we can apply our modus ponens rule.
Ponies.
Yeah, ponies. Exactly.
Pony.
If you want to think about it that way, that's fine.
Okay,
It's
so
distracting.
3 and 4.
Questions so far? There's no stupid well, there are some stupid questions, but
I ask a lot of airheaded questions, but it always leads to like the answer. So
yeah, I mean, as long as you're being relevant, there's not really a stupid question. Like, if you ask me if pigs can fly, then that would be a stupid question, but
because I learn things backwards, so I
yeah,
might get things a little bit.
sure. Is this
messed
making
up.
sense to everybody so far?
Yes.
Okay, good. So let's look at add rule. Add rule is funny. Add rule is my favorite rule. Add rule is my favorite. Let's do add rule and simplification.
Simp.
Simp.
I was gonna say.
Yeah. When I teach this to actual students, I don't make that joke, but I guess I can make it in Discord. You're a
Heck
simp
yeah.
if you use simp. Okay. So these two rules are kind of interesting. And again, if you want to do a truth table, you can do one for these and you'll find out that they're true. They're valid arguments. If you don't know how to do a truth table, you can watch the last one in the Arthuria Times place. They're on YouTube. But simplification basically says if I have a statement that's like A and B, I am justified in writing each one individually.
So would you say simps are valid?
Yeah, simps are always valid.
What about the right?
The
The right
what?
side of your equation. If you say A and B
Yeah.
are true, then something happens. Can you separate them?
Yeah, so like if A and B are true, I could write B here if I wanted to by simp.
What does the dot mean between P and Q?
That's just the way that he does and. Just
And
that.
okay, so that's the
just
and symbol.
Yeah,
Okay.
sorry. That's just
P and Q.
symbol.
Okay.
The bot works with the ampersand, so like his horseshoe is for if then.
Yeah, that's thank
Yeah.
you.
So yeah. But anyway. So again, the way you can think about this is if I tell you I have apples and a basket, right? I have both the apples and the basket. It follows that I have a basket. It's pretty simple.
Sure.
Add rule exploits the inclusive or. So add rule says if I know that you have apples, right? I know that it's true that you either have apples or you have a basket. All right?
Or
Yeah, or.
uh,
Because you have the apples, right? This or statement, apples or basket, is going to be true.
yeah. You can say or if you have both.
There are two types of or. There's inclusive or, which is like and or, and there's exclusive or, which is A or B, but not both.
Yeah.
And
we'll
which is
talk
in this
about-
case?
This is inclusive. This
Yeah,
is
this is
and.
inclusive.
Oh yeah, okay.
This can be
I was
both.
thinking, yeah, okay.
Yeah. We will discuss the exclusive or next time because there's only one rule that you can really use with it. To be as minimalist as possible with the exclusive or, there's only one rule that you can use with it. There's like a trick though, but we're dealing with inclusive or. And again, the way to think about it is that if you go up to a restaurant and the guy asks you, "Do you want a hot burger?" A hot dog or a hamburger, he asks you that question, you could
On
order
both.
both. You could
On
order
board.
both. Right. Inclusive one. Okay. So, I mean, we can do a simple problem doing a combination with this. Let's use Modus Tollens as well. So I'll give you A and B. Hotborg. Yeah, correct. 2, I will say if A or C is true, then D is true. I want you to prove that D is true. Anybody have any opening move suggestions?
Okay.
Well, you could just separate A and B and just say A.
Correct. Always simp your and statements. This is number one rule. Always simp and statements. That should be your first move. And whenever
And
you
three,
see a
two.
loose and statement, always just simp them. It doesn't matter if you're using them or not, just always do it. And if you don't use it, who cares? Just simp your and statement. So loose letters are always better. Okay. So we're here. Now what do we do?
3-2, my pony.
Pardon? Oh, my pony. Okay, so good idea. So you want to say that 3 and 2 Modus Tollens is right? Sure. But is A this left side in parentheses?
Yes.
Yeah, I thought
No, it's not. It's not the same. Logic is stupid. You're a move ahead. For our purposes, A is different than A or C. Those are different statements. We can't Modus Tollens yet. Because remember, Modus Tollens wants the exact left and the left side. It wants the exact
Yeah.
left side.
So we have to do an add.
We have to do an add. We have to do an intermediate statement. Correct. Good idea though. You're perfectly on track. You just
A
A or C.
or C.
Add
So
C.
add rule of 4.
Add 4. So
And then
add
C.
B.
Well, now
Oh,
we can do a modus
Or
ponens.
you're right, Pancake. You're right. I messed that up. And now we can do the modus ponens. Right, which would be MP of 5, 2. And we get the star because we just won.
Okay, so since you took out the parentheses, it's no longer 2 things. It's 1. What?
So this guy, we only need parentheses for what's called complex statements that have more than one operator.
Okay.
Yeah. Yeah. Like
Because
see
if
how
I
it's
took
D.
this out, of the way, right? Is this saying A, or if C then D?
Yeah, okay.
Or is it saying that A or C, if A or C is true, then D is true? There's like 2 ways to read it, right? And so that's why we need the parentheses. There's only one way to read this. So we don't need them. You could. There's nothing wrong with doing this. There's nothing wrong.
Oh.
There's nothing wrong.
Okay. But because there's not anything extra, you don't necessarily need the parentheses.
Yeah, you don't need them.
Okay.
But some people like to put them there for clarity.
Yeah, I like that. Okay.
I can do it that way if the room desires it.
I personally like the separation because I'm new to this and
Fair.
seeing it visually helps.
Okay.
But,
Sure.
you know,
Okay. Yeah, okay. Let's do my favorite problem. Oh, we need another rule. So let's learn another rule called disjunctive syllogism.
oh god.
All right.
Just giving us
Big
the
name
big ol'
for
one.
Coming from
simple
add.
rule.
Oh
Oh.
god, no.
Big name for simple rule that you all already know. So I have either a basket or I have apples. Right? This is B or A.
Okay.
I do not have apples. What can I conclude?
B?
So I'm telling you, I either have the basket or I have apples. I do not have apples.
Ergo, you have a basket.
Correct. I have a basket.
So
Yay.
Don't
I
you say
have
that.
B.
That makes me feel dumb.
Absolutely correct. Now, if I told you, so you see that
Good
there's
job.
2.
Well done.
Yeah,
Thank you.
great job.
She's
You
starting
see
to think in binary.
Yeah. You
That's
see
progress.
that there are 2 of these, right? There are 2 of these,
Yes.
right?
Yeah.
Why are there 2 of them? Well, if I told you that I do not have a basket, right? So not B, right? I can conclude that I have apples.
And then
Yeah.
you can say, how do you like them apples?
Exactly.
Huh.
That's one of the reasons I use the apples and basket example, and it has nothing to do with them working with the first 2 letters of the alphabet.
Nice.
Nothing to do with that.
I like them apples.
Okay. So with this rule in mind, we can do something fun. So I'm going to put it up there, using this DS rule, using the simp rule, and then using add rule, we will prove this is true. A and not A. Oh, I meant to do parentheses. So A and not A. Ergo, Z is true.
Why Z?
Because it can be anything, and I like doing Z
Okay.
because it screws with people.
Okay.
Z is nowhere in here. This is a contradiction. This is both I have apples and I do not have apples.
Oh god, no.
So what is my first number 1 rule of logic? Simp your and statements. And then we're going to go from there. Simp of 1, 3,
Not
not A.
1.
simp of 1. Okay. So I'm here. How do I get to Z?
Oh god.
You don't.
I can in 2 steps. I have to use add and DS now.
Oh, so you could add Z.
To what line?
Oh shit.
I would say not A, because then we're gonna do a disjunctive. So
Yeah.
not so add to 3.
So you can do it this way. It's actually a step longer, so you don't want to do that.
Oh,
And we don't have the rule for double negation yet.
okay.
But you could. I'll show it that way. After this. So you can add A or Z through add rule. Add rule of 2. And then we see, funnily enough, right? Lines 3 and lines 4 match our DS rule.
Huh.
Oh yeah. Yeah, it's just kind of flipped.
Yes. Yeah, it's it would be this guy. Yeah, it's just flipped. Yeah.
Okay.
And so then we can write Z.
that's cute. So Z?
Yep, Z through DS of
3 and
4 and
4.
3. Yeah, 4 and 3 and 4. The order here doesn't matter.
Okay.
Yeah. But there you go. So we're not learning replacement rules yet, but I'll do it Arco's way.
Okay.
So we'll add to line 3 instead. Technically this is a replacement rule, but it's pretty simple. It's called double negation.
Oh god.
So with double negation, all the double negation says is I can put 2 knots in front of anything, right? Or I can take
Becomes
2 knots
positive,
away.
right?
View the dots here as an equal sign. So I can either put 2 knots in front of something or take 2 knots away. So here, it takes an extra step, but I can write, it isn't true that A is false with double negation of line 2, and then because noting here, if we use the parentheses, right, this is negating the left, this is negating,
Okay.
this is a negation of this, right?
Okay.
And so it's still, it's the same process,
And then
basically.
Z. Okay.
DS of
Okay.
5 and 4.
So that's actually where my mind went immediately. It went immediately to Z.
Yep, good. It should. So
But
when you get good at these
wow.
things, this pattern, you just instantly see these 2 statements as being the line 6. And that's how you beat PL
Yeah,
dot
that's
quickly.
my mind completely bypassed 4 and 5 and went immediately to 6.
Yeah, sure.
Well,
Okay. So this is why from a contradiction, everything follows,
Mm.
by the way. Now, I could be cool and say, hey, I want to prove some junk.
Yeah.
Let's prove some junk. Whatever this junk is, right? It doesn't matter.
put it
because
in.
Add rule just applies here.
Easy.
It's the same thing.
Yeah, I can add whatever I
Okay.
want. It doesn't matter. I can add complex statements. I can add literally whatever the hell I want.
Okay.
That's the beauty. This is why add rule is my favorite rule.
Interesting.
It's like
Yeah.
Minecraft.
Yeah, you can add whatever you want.
Yeah.
But again,
Create a
literally like what?
It's like Roblox.
Shut up.
but noting you can't just add out of oblivion, right? You're
Yeah.
adding to a line, right? It's always a line, the same line that you're adding to, or your junk, right? Limits of add rule.
Oh my god, guys, I'm learning.
Yeah, good. Constructive Dilemma is garbage and I hate it, so we're not going to talk about it.
I
For
like
now.
that. Cool.
We're going to look at hypothetical syllogism, the cousin of disjunctive syllogism. So this is also known as how slippery slopes work. Is through hypothetical syllogism. So, example I like, if you smoke the ganja,
Yeah, my
then
brother.
you will get addicted. Okay.
No.
Well, it's a slippery slope. If you get addicted, then you will take more drugs. If you take more drugs, then you will be homeless. If you are homeless, then you will be dead.
All right, so it's just going down. No holding
Yes.
back.
So if you smoke the ganja, you die.
Yeah.
Correct. So let's formalize this into logic. Let's say
What's
that
time?
this is yeah, right. So let's formalize this thought into logic. So premise 1 would be if you smoke, then you get addicted.
Mm-hmm.
Premise 2 will be if you're addicted, then you're going to take more drugs. Let's say D, or let's do T. 3, if you take more drugs, so if T, then you'll be homeless, which is H. And then if H, then you dead, which is never fun. Prove to me that if you smoke, then you're gonna be dead. So again,
Oh, this is.
so the way to think about a hypothetical syllogism is if we look here, it's also known as like the crisscross rule.
ST.
Crisscross.
So I mean, you can think about it this way. You were all crisscrossed in high school. I don't know, trying to make a pun with the HS. I don't know how to do it. Something high school
High
crisscross
school.
related. I don't know. But you see here, A is on the left, right, and A is on the right here. And so basically we just drop the other two down. So we'll drop S and we'll drop T down and they'll keep their same places. Which would be if you smoke, right, then you'll take more drugs. And this would be hypothetical syllogism of 1 and 2. 6. Now is where things get a little bit more tricky.
Okay, so smoking takes and
Can you just say T then H then D?
Correct. Exactly.
I sloped down the slope.
Yeah, this is the slippery slope, right? So we
Having fun.
see that T is on the right here, right? And T is on the left here. So we have our crisscross in high school rule to apply.
Oh, so are we going to eventually end up with a third hypothetical syllogism?
Yeah, we will. So
Okay.
if S then H, and this time we're still in high school, right? But it's the world of 2 and 5 high school. Now you're correct, Argo, because H also crisscrosses here in 4.
Well, that's right.
So then if you smoke, then you dead.
I have empirical data that this is unsound.
Same. I can actually prove this as being correct.
My mind just bypasses all this shit and goes immediately to S to D.
I may or may not be smoking the ganja right now.
Oh god damn it!
I've
Argo.
been
Well,
doing
you're
that too.
straight to homelessness,
Argo,
and then you're straight
high
to death.
five.
So this
In
would
class,
be
let's go.
what would this be? This would be like 4 and 6.
Oh
So
my god. Wait, four is.
while I was right that there would be 3, I was wrong about how 3 would be used. Because I was imagining, like, instead of always starting with S,
Yeah, that's what I was thinking too.
I was imagining, like, hypothetical syllogism of S to T, and then a hypothetical syllogism of T to D, and then a hypothetical syllogism of ST D.
Okay.
What?
So let's say that you're like Arco, and you're being a
You're
very
like
bad
Argo.
boy. And you're being a very bad boy, and you are
Yeah.
smoking the ganja right now.
It's THC. That's what it is.
Ah,
Okay, so you have to change the letters to THC.
it spells SAT.
Let's go.
It does, sat.
Wait,
I
Whatever.
realized.
So that 5, 6, and 7 would be THC at the end. So H implies C, and then you'd have THC in it.
Okay.
Oh,
THC
no.
bad. That's what
I'm
you were.
gonna say
So number 4 should be H
Yeah,
implies D.
psychologically
Yeah.
crushed.
Psilocybinally crushed too.
Yeah, yeah.
Psilocybinally.
I'm so happy. I'm so happy this happened.
Great. Yeah, that's actually kind of funny.
I'm sorry.
I should use this.
Better than
You should use
AIDS.
it in class.
Yeah, I should. I actually have run something like this in class for like Slippery Slope because they all know like the DARE program or whatever.
Yeah.
It's like they can immediately like recognize that type of logic as this. And so I'm gonna do psychologically crushed now.
Do it, yeah.
I'm gonna do it and see how many people get it.
Dare made me want to try this.
Okay,
Exactly.
so now if we're here, right, and instead of proving this, I just want to prove that you're gonna be psychologically crushed.
THC. I'm so happy. I'm sorry.
That's good.
So
That's
now we're
very
gonna. Were you gonna show like the bad argument that I thought it was gonna be?
Yeah. So like if we have S now, right?
Okay.
So we know that you're smoking now,
Oh God.
right?
I'm gonna
So
die.
then we know that you're going to be psychologically crushed. But what rules do I use here to derive this?
Mm.
This is like where practice makes perfect. Is being able to see all the different patterns at once.
Wait, is this a combo or are we
Who are you
still
talking to?
using HS?
This is a combo. It's not HS.
Oh God, I was thinking it was a combo. No, which combo would it be
We're
then?
using one of these rules.
Wait, what
I
do you have? What do we have to do?
Which one?
You have to
We're
prove that
using-
C is true
From where?
from all of these lines.
And you have to use one
it's
of
at
the implication
number 8?
rules.
Yeah, so you're going to use number 8. Good.
Question number 8.
You're not using number 8. You're using 8 is just the next line.
Eight is
Yeah, sure. 8.
You can't use the line you're justifying. I'm trying to write C, and I can only use these guys, the guys above it.
Oh, you could do a modus ponens from 5 and 7.
Correct. Modus Tollens of 5 and 7. Why? Because S is here, and guess what? S is the left side of the if-then statement.
Oh,
That's this guy.
okay. Thank you, Arco. Okay,
Sneaky.
So wait, modus ponens is P equals Q or P then Q, right? Right?
Yeah, if P then Q.
If P then Q. Okay.
P is true, therefore Q is true.
Okay.
Is it
So-
possible
If I
to
have this
phrase?
guy, I get this guy.
Is it possible to flip the order of the modus ponens where it's P, if P then Q, Q?
If P then Q, Q ergo P.
No. Just flip the order. So instead of starting with the if then statement, you start with the P.
Yeah, it doesn't matter. Like that's what's
Okay.
happening here, right? Like 5 is above 7. It doesn't matter. The order doesn't matter. As long as you
Okay.
have the two things above the line somewhere, you're good to go.
Okay, cool. Yeah, I've just noticed like people use modus ponens in different ways. Where like they'll do premise 1 P, premise 2 P if P then Q.
Yeah, that's fine.
Conclusion. Okay.
That's fine. That's fine. There's no right or wrong way. Order doesn't matter.
Interesting.
Okay, what's the alternative way to solve this without using hypothetical syllogism? I like showing this problem because it kind of blows people's minds.
So
I can't use hypothetical syllogism.
I feel like you could just it seems to me like you could simp hypothetical syllogisms into a bunch of modus ponens.
Correct. It would just be a series of modus ponens. I would write A through modus ponens of line 5 and 1.
Yeah.
From A, right? I see that A is the left side of this guy. So then I can
Yeah,
write
Why does HS exist?
Why does
Like-
HS exist?
It's like you could make them like up to infinity, like 5 of them or something. It's like
Yeah, yeah, you can do into infinity. But the reason why would HS exist? Because you're not always being able to modus ponens things. Here's an example.
Can you just separate them? Add?
You cannot separate. What are you trying to
Oh,
separate?
because they're not ands. What can you separate again? Just
You
ands?
can separate and statements. So like, if A and B, then I
Yeah,
can
that's-
write A and B.
That makes sense.
It's the only thing you can do it for it. You cannot do it with or statements. That's a big no-no. You cannot. This does not follow. Cannot
That
do
doesn't
that
doesn't follow logic.
because B could be true. B could be true, and A could be false, and this statement is still true.
Mm-hmm.
So you have no clue. Why are you asserting A is true when B could be true?
Absolutely. What's the horseshoe again?
It's if then.
Okay.
Yeah, the horseshoe is if then. Sorry, this book uses different symbols, but I'm using the ones for the bot. Yeah. Okay. All right, let me talk about constructive dilemma, but it's freaking stupid and I hate it.
It's okay.
It's the only one that we haven't talked about. Oh, we haven't talked about conj. Conj is silly. So
Is that sort of the opposite of simping?
it's the opposite of simp. It's kind of silly. So if I were to write A or B, and then line 3 was if D, then C, and I said I want you to prove that A or B is true, and if D, then C is true. Right? If I want to prove this statement, right, it's literally just conj. So I could just write this statement with conj rule. I guess I've screwed up. But all that conj does is I can take 2 lines and put them together with an and. That's all that conj does.
Any line?
Any 2 lines. Any 2 lines you can put together with an and statement. Because you're assuming that this is true and you're assuming that this is true.
Yeah, so why wouldn't they both be? Yeah.
Yeah, right, exactly. Why wouldn't they both be?
No, it's so logical, but it's like I'm pushing intuition back. That's how it feels. I don't know.
Good, I think
Yeah.
you should be. You should think like you're stupid. Because
Yeah.
logic is like a computer program. It's
I know.
very
I think it'd be easier if you like asked problem. I don't know if you've done this, but like put problems and ask if they're correct instead of asking to prove them.
okay.
I don't know.
I mean,
I'm not saying do that. I'm just saying like it would be less, but it feels good to push down intuition because you have to grow sometimes. You know?
yeah, let's talk about constructive dilemma and then we can do practice problems like that. Okay?
All right.
How about that? Let's get all the rules on the board. Because then we
Yeah.
have all 8 rules. And the people on YouTube who don't want to listen to the practice problem will like this better.
Okay.
So constructive dilemma. Oh, my head hurts already. Oh my god.
It's okay.
Okay. So the intuition behind constructive dilemma is, let's say if A is true, then B is true. Okay. Now let's say that if, I don't know, some C is true, then some D is true. Now you know that either A or C has to be true. And we're going to conclude B or D. Now, the intuition behind this rule is one of these 2 guys is going to end up getting modus ponens, right? One of them is because either A is true, right? Either A is true and then B becomes true, right?
Mm,
Or C
Which is
is
it?
true, right? And then D becomes true,
yeah, it's inevitable.
right? Knowing that it's inclusive or, so both B and D could be true together as well, because both of these could be true. But the or statement solves this issue. So because all of our rules are no more than 2 lines, we need to put these two puppies together. So you put them together in one line so that the rule only has to be 2 lines. That's the only reason that this exists. The order again does not matter. Order of and statement does not matter. The order of an or statement doesn't matter. The order of an if and only if statement doesn't matter. But the order of an if then statement, very important. Order of an if then statement is very important. Extremely important, actually. And then we could say here, again, the trick is you have the 2 left sides connected by an or, and then you get the 2 right sides connected by an or. So it would just be D or B, or sorry, D or B. This would be CD of like 4 and 3. That's constructive dilemma rule, which is stupid. I don't like it. It makes my head hurt. Anyway. So that's all the rules. Any questions about the rules?
Yeah, you mentioned something like this one can be proven with modus ponens.
Which one?
The constructive dilemma.
Yeah,
Maybe
so like either A is true, right? And then this is going to be modus ponens, right?
Uh-huh.
Or C is true, and then this guy's going to be modus ponens.
Oh, okay.
That's all I meant by that.
I see. Gotcha.
All right. Let's do some problems. Sometimes I'm good enough to think of these on the spot, but I think I'm going to cheat this time. That's okay with people. Okay, that's the problem set we need. Okay, let me see, guy. So this is just going to HS all the way, I think. Okay. Okay. This guy looks tricky. 7 looks fun.
Let's do 7.
Looks fun, eh?
I'm going to use your suggestion, and I'm going to just do it and see if you can spot where I make an error.
Okay, what's the horseshoe is if then, yeah.
Yeah, it's if. Then.
Yeah.
Sorry, this book is kind of garbage.
I don't know why I can't like wrap my head around it.
There's even another symbol that people use, but I forget what it was.
So what's our task with this?
What do you mean?
Are we supposed to
you
be
want my homework?
identifying the 8 rules, or are we supposed to try and see?
I'm going to do some of the problem, and then you are going to tell me where I messed up.
All right.
And just to shout if I make an error, basically.
Oh God.
Because 6. I'm going to say that R is true. And what are we trying to prove? Oh, this is stupid. Let me see if there's a better one to prove for this. Let's prove. Oh, this is the answers. Funny. Yeah, this is the answers. Okay. Well, that's stupid. Why is it giving me the answers? Misprint. Don't look at the bottom. It's giving me the answers.
I've never looked.
Yeah, give me the answers. Unfortunately. Okay. So we're gonna go here, and we're trying to prove that R is true. Okay. Yeah, I know.
But what about 4? You have 4 shown there.
Oh,
Yeah, don't look at 4.
Okay, cool.
it was hard to remember. I don't know if I can remember it.
You
So
can
we
do
want-
this in many orders.
So we want to prove R is true
Yeah.
using
R-
the 8 rules of implication.
Yeah, R is here.
Not Q.
Can we
If
have like
not
a
Q,
second?
then R.
So I'm going to write something, and you tell me if I'm doing this right. Okay. I'm going to write P is true through modus tollens of 1 and 2. Then
No.
I'm going to write that I'm going to write that not Q, if not Q, then R is true through a DS of 4 and 3.
How is
I'm gonna-
4 right?
Yeah, it's not.
Oh,
And then I'm going to write R is true through modus ponens of 1 and 5.
Yeah.
So where's there's two errors in this. What are the two errors?
Well, it's 4 because P is not true.
Correct. 4 is wrong because if we remember our modus, let me actually, whatever. Screw it. So if we go back to our famous rule sheet or Bible, not these rules. No one cares about these rules. So if we look at Modus Tollens in our rule sheet, right?
Yeah.
We see that I forgot to add a negation, right?
Yeah.
Because when not Q, Modus Tollens is this, it should be not P. And now the problem actually works, right? Now the problem works, funnily enough. Because not P here, right, does make a disjunctive syllogism with 3. Right? But if this,
yeah.
right, because this is the DS looking at the rule below it, right? This is the negation of this.
It is.
So then we can write the right side.
I don't think I have a strong enough grasp of like each of the implications yet in order to differentiate
So
them.
again, this is just saying like if I have apples or I have a basket,
Right.
I don't have apples, therefore I have a basket. Here, my apples are
Yeah.
this P,
Why is
right?
it so hard to understand, but it's so easy to understand?
And then my basket is this garbage. That's my basket.
Right.
Is that garbage? I don't have the apples, so I get the basket. Does that make sense, Arco? Maybe, maybe
Yeah.
not.
Yeah. I just like it makes sense once I know what implications are being used. But if I just look at the blank problem, I have a hard time recalling. Like when you say a disjunctive syllogism, it takes me a long time to like remember what that is. And then after remembering what that is, it takes me a while to like find it in the problem.
Yeah, this is just practice makes perfect. This is just
Yeah.
practice makes perfect. It takes a long time to get good at this. But the advantage is once you do get good at this, you can do them in your head. Because I can just instantly see, oh, this modus tollens, right? So I'm just holding not P in my brain. I'm just holding this not P in my brain. And then I'm looking around and I'm saying, what does not P do for me? Oh, it modus tollens is this. So I'm holding this guy in my brain right now.
Yeah.
And then I'm saying, oh, wait, this guy modus ponens is with that. And so now I have R in my brain. And I'm like, oh, it's valid. And that's how you beat PL, that's how you beat PL bot quickly.
Nice.
So take it one step at a time. That's why I like doing it one step at a time, because that's the way that you think about how to solve problems, I think.
Right.
Let's do another one. I don't really like this finding errors. I'm not sure I'm a fan. Personally. Just me personally. I should open up another copy of this, but I don't really want to. Yeah, okay, good. So this is the correct problem set. Let me go to one that doesn't have answers because that's no fun. These are intended for you. Oh, this is a good guy. Let's do 26. He looks difficult. Actually, let's do an easier one. 21. It's easier. It looks easier. Yeah, this guy's easier. I see how to do him. Or at least I'm like 50% of the way there. So let's do if R, then P is true. 2. Oh man, this is some junk. I don't like this junk. I'm already scared.
You spoiled it.
Not R. And then S and not R. That's a weird statement. Yeah, that's a weird statement. Not P. 4. P or Q. We're trying to get S. Okay. Yeah, this will make your head burn.
You can make MT with 1 3.
Correct. Good idea. So there are two ways to solve the problem. One way is solving the problem backwards. The other way is just applying rules until you get there. I'm a fan of both. So let's solve it by just applying rules. So you're right. The first move, and I think a genuinely good rule, we can MT 1 3 and 1, right?
Mm-hmm.
Which gives us what?
Not R.
Not R. Through Modus Tollens of lines 1 and 3. Okay, good.
You can do Q. Q, then Q, if, then S.
Okay, good. Okay, so what was the first thing you said there?
Q, well, Q, I don't fucking know. Q, if, then S. That's the name. I'm trying to search name of like.
Implies.
Yeah, implies. Thank you.
S.
So Q implies S because
How-
not R is true, or R is false, rather.
Q implies S because
Does
R
that
is
make
false?
sense? Wait,
I don't think so.
if Q and R are false, you don't know anything about Q. I'm sorry, I'm just.
Yeah, I don't know
confused.
anything about Q yet.
Yeah.
I actually do know something about Q, which should be your next rule. Actually,
Is
Oh,
it?
shit.
Are you talking about not R being present in both of number 2?
Yeah,
So
it's
if you
weird.
combine not R
Yeah.
and the other stuff, then you're left with just Q.
Algebra brain.
If Q, then S.
But I
Yeah,
just
it
saw
doesn't work like
4.
that. It doesn't work like that, unfortunately. I wish it could, but yeah, good ideas. Good ideas.
Q is
S
true.
is here, though. We know S is here. So what do I need to get S out of this chunk? How
You
would I
need the
get
simp rule.
No, I
Yeah.
can't simp if-then statements. What gives me the right side of an if-then statement?
Modus Ponens.
Correct. And what do I need for modus ponens? I would need this guy. So if I got this guy, then I would win.
Oh,
Because
yeah.
I will get this guy, and then I will simp it, and I'll win. So
3
if
and 4 something.
yeah, 3 and 4 is the trick. But I'm looking for this guy. So how do I build this guy? Right? Well, I have part of it, right?
Yeah, you
not
have 5.
Well, you have Q2.
You could
How
do a
do I-
Modus Tollens with 4 and 3.
4 and 3. Correct. It's actually called a DS because it's an OR
Oh,
statement.
sorry.
Yeah, but you were right. You were completely correct. You knew what you were talking about. So that's 3 and 4,
Yeah.
right?
So now we have Q,
Now I have Q.
and
Add.
then you do 6 and. Oh yeah, sorry, add.
Again, can I build how can I build this guy? What rule lets me build this with 5 and 6?
And add.
Not add. Close. It's the sister of add. Just the conj rule.
Oh, shit.
Yeah, this is just practice, right? Because what I'm saying is I can write both of these two lines together with an and statement. Why not?
So now it's MP 27.
Correct. Now it's MP. So I get S and not R with the modus ponens rule of 7 and 2. And then
Insane.
9, I get S with my, correct, like Arco said, which I did not correctly tell him was correct. Because now I know what he was thinking. We get simp of 8, and we're good. And we get a star. If we were victorious.
Who's eating an apple?
I'm eating an apple.
Do you have a basket?
No.
I
Actually, I do. Well, there you go.
that's-
You have an
that's
apple,
correct.
then you have a
That's
basket.
correct.
He has an apple. Therefore, he has a basket. It's true. It's sound argument.
Thought it was an exclusive or, my bad.
Okay. If you want to talk about what exclusive or okay, let's. I mean, I think we've gone for an hour and we've covered all the rules. This might be good enough for today, unless people want me to go on more. We could do another.
I just need to practice doing these things.
Yeah.
So if I got the baronet book, I could just practice these equations, right?
Or the Hurley book. Both.
Or the Hurley.
Yeah. Any book that has logic in this form, you can practice them. And
Okay.
I'm more than willing to look over your solutions.
Thanks,
So,
CoolDog.
Just make sure you have the problem on there. Otherwise,
Right.
what the fuck is this? I don't fucking know. Right?
Right, okay.
Have the problem on there. And then we'll be good to go, I think. And you can send me, I'm more than happy to look over whatever problems you do. Doing these is very quick to check. It doesn't really bother me at all.
Okay, thank you.
Yeah, so looking forward to next time. We are going to build on this understanding, and we are going to use the 10 replacement rules. If you want to work ahead, view these on the worksheet, view these dots as equal signs. And you can apply these rules inside of parentheses. So whenever you have something of the form of P or Q, for example, you can just switch the order. De Morgan's is an important rule, and then material equivalency is the most important rule on this sheet because it's the only rule that applies to an if and only if statement.
Okay.
But yeah, other than that, transposition's kind of funny. Not technically necessary. The other most important rule is going to be your material implication rule. Is your other most important rule. But yeah, other than that, unless you have questions, I'm pretty sure we can end it here.
This was
Great.
fun.
Yeah, thank
Okay.
you, CoolDog. I really appreciate
No problem.
Really fun. THC.
Glad that you enjoyed it.
Yeah.
Yeah.